Hi, I'm Matt at Canaan Avionics. We make the U1713 digital interface adapter or module. It can convert signals like 429, CSDB to analogs, digitals, Modbus, anything that you need converted on your aircraft or special missions project, let us know. We also make, as far as tools, we make probably the best 429 tool there is, the 429 Data Server 2004. And it has 4 transmitters, 8 receivers. It has a connector on the back that lets you install wires into a connection. It can survive level 3 pin injection for DO-160. It has 4 transmitters and 8 receivers, but it has some really good software that goes with it that's for free. So today we want to show you the U2004, how it can interface with our GTN-625, and the first step is to go to the website and download the software. So the software that we have is called Canvas, and it interfaces with the U2004 and other Canaan Avionics products, but it gives you a front-end interface to interface with these tools and provides you digital readouts in engineering units. And there's no royalty or fee for using this, and it will be free in perpetuity. So go ahead and download the latest version, whichever version you need, from our website, and read some of the instructions. This instruction here is for developing your own ICD, interconnect definition files, and then we have some examples that you can do in Python as well. The software allows you to connect to the U2004 and other Canaan products. And in this case, we are connected to the 2004, which, if you remember, we are connected to a Garmin GTN-625. And right now, we can choose an ICD, but what the data looks like without the ICD is just a bunch of ones and zeros. So if I hit run on this port, we can see the labels coming through here, and the hex, the binary, and then because we don't have an ICD, we don't have engineering units. Saving data recordings is as easy as just hitting save, and then you can choose, however long you want that recording. And it will bring up the recording, and you can save it as a CSV, a text file, whatever you need. You can import it into Excel. But in the meantime, I'm going to open an ICD file. I'm going to choose Garmin GTN bus. And as you can see, distance to go, 12 miles, time to go, 5 minutes, ground speed. And what it does is it converts these ones and zeros into these engineering units. If I pause this port, for example, and it says that the Greenwich Mean Time is 15 hours. If I make that 12 hours, it will go through and update these to represent that amount of time. If I hit run on this, it will overwrite it because this is a receive port. So that's how you set things. If you want to set SSM, you can type in no computed value, or you can type in the number 3 and get valid over there, and so on. So even though that the U2004 is wired to the Garmin, we're getting this message right here, which indicates that we are missing, data sources and stuff like that. So let's add them. So here I've made an XML file that I call Garmin EFIS, and what it does is it creates the definition for ARINC 429 words in an XML format. XML is nice because it's object-oriented, it's hierarchical, and it gives the ability to define parameters, enumerations for the parameters, and that sort of thing. For the schema, again, go to our website and you can see what schema that Canvas accepts. If I go to Canvas, I can choose this ICD. I already have it selected here. So if I go to Garmin EFIS, it will load this ICD. I can run the port afterwards, and it will start transmitting the Garmin EFIS bus data. And as you can see, all these parameters are available for us. So I want to, Barrow standard altitude, for example, has failed. I want to make that pass. I've set it to 2,000 feet. Maybe I want it to be 10,000 feet. And that's how you do that. All of these enumerations work exactly like that. You can choose left, right, center. I can actually type in the word right, and it will go to the right and set the SDI bits for that. So for now, this is how we have them all set. So computed airspeed, air temperature, that kind of stuff can be set like this manually, or you can even change the bits over here, for example. So if I just put a couple ones in there, you can see that that's the bit weight of those bits. You can change the SSM. If I wanted to make that 10, now it's in test mode. If I want to make this 11, I could do it like that. Or I could come in here and I could change, let's just make that a 0, and you'll see it tried to change the parity bit, but the parity bit got set on the next transmission, so it's failed. So I can change that back to valid. And that's how this works. With the data coming out of the U2004 paused, I get the same message because the Garmin needs some data to function. If I run this port, which I just clicked run, and we have an activity light, if I come over to message, you can see that those failures have been removed. Now that we have the data going into the Garmin, we can do things like manipulate the data. So these right here where it says magnetic heading, that's a well-known name. So everywhere that you see that, that means that that one parameter identifies as magnetic heading. So anywhere that it's used or set, it gets reflected in the ARINC 429 data. This goes to whether it's transmitted or received. Right now we set it to 0 degrees. In Python, again, there's some examples of the Python in our website. You can see that we can connect to Canvas using just an IP address. So whatever our local IP address is, we can connect to it, and then we can run this little script where we take heading and we run a loop. So interesting thing about heading is that some can go from 0 to 360, some can't. So if I try to put 360 in here, it maxes out at 180 degrees, and that's what the bits are. So the max is all ones, and you can see that the sign bit is not set. If I go negative 360, again, Canvas sorts all this out for you. You can see that only the sign bit is set, and it's all zeros. So that's the most negative that this parameter can go. So not wanting to do that manually, I can create a little loop where I can set heading. I can make it a mod of 360. I can normalize it by subtracting it 180 from it. That gives me a heading that's between negative 180 and positive 180. And then all I got to do is tell Canvas through this one command, set magnetic heading to normalize heading, sleep at 0.1. And then when I run this, do I want to connect to this IP address? Yes. And now I believe it is running. I could put a print, but I didn't. And now you can see that the heading is being slewed. And on the Garmin, the aircraft is circling around in circles to reflect the ARINC 429 magnetic heading that I sent into it. Not forgetting to mention that Canvas also works with my business card. I give these away. Instructions are on my website. And basically you just plug in 429 into here, and then you get ARINC 429 activity. And the same ICD and the same features for any one of these receive ports works with some limitations. But if you need one of these, just order from our website. Thank you.